Welcome back, everyone. Today, we're diving straight into a really exciting explainer covering Section 8.2 of your textbook. We're talking about test-driven development. If you want to understand exactly how modern software is built reliably, you absolutely have to understand this. It is a completely vital and transformative concept in software engineering. We're going to treat this just like our regular university lectures, but highly focused and super easy to follow. We're going to break down exactly what test-driven development actually is, why it flips traditional programming completely on its head, and why the industry literally cannot get enough of it.
Here is our quick roadmap for today. We'll start with a solid introduction to the concept, then walk step by step through the 5-stage cycle you'll be using in practice. After that, we'll look at the core benefits as well as the real-world limitations. Finally, we'll wrap up with a summary specifically designed to highlight what you absolutely must memorize for your exams.
All right, let's kick things off with Section 1, a quick introduction to TDD, focusing on what it is and where it came from. So, the most crucial thing to realize right out of the gate is that TDD flips traditional programming totally upside down. Historically, developers would sit down, write a massive program, sometimes taking weeks or even months, and only test the whole thing right at the very end. Test-driven development, or TDD, completely changes the game. As our definition points out, you write executable tests before you even write a single line of the program code. You interleave your testing and your coding in tiny, easily manageable increments. Basically, you don't move on to the next piece of functionality until the code you literally just wrote passes its tests. Now, you might be wondering, where did this radical idea even come from? Well, it originally emerged from agile frameworks, specifically a method known as extreme programming, or XP. But over the years, it proved so incredibly effective that it spread like wildfire and broke right out of its agile roots. It's now a completely mainstream industry standard. Today, you're going to find TDD being used not just in agile environments, but also in very traditional plan-based software processes. It's everywhere. So just to quickly recap our first topic, TDD is an industry standard practice where we write automated tests before writing our code, and we work in continuous, tiny increments. Moving right along to Section 2, the 5-step TDD cycle. Let's look at exactly how this works in practice. Think of the TDD process as a continuous, repeating loop. You're constantly moving from writing a test, to watching it fail, to implementing the code, and then looping right back around. It's a fantastic way of visualizing exactly how functionality is systematically identified, tested, implemented, and refined over and over again. Let's break down these 5 steps slowly, as if you're trying this for the very first time. Step 1, you identify a tiny chunk of functionality. We're talking about something small enough to be implemented in just a handful of lines of code. Step 2, you write an automated test for this exact specific feature. Step 3, you run the test and you watch it fail. Now, a lot of students ask me, wait, why on earth do we want it to fail? Well, this is actually a fantastic thing. It proves that your test is actually checking for something brand new and that your system doesn't accidentally already do what you're trying to build. Step 4, you implement just enough code to make that specific test pass. Once it passes, you refactor, which simply means you clean up the code and improve its structure without changing its underlying behavior. And finally, Step 5, once all your tests are running successfully, you repeat the entire process for the next tiny chunk. Now, to realistically do this in a modern development environment, you literally cannot test this by hand. Because you're developing in such tiny increments, you need to rapidly run hundreds, sometimes thousands of these test cycles in mere seconds. To pull that off, you absolutely need an automated testing framework. A really great example is JUnit, which is heavily used for Java programs. The tests are embedded in a separate program that invokes the system you're building, doing all the heavy lifting automatically behind the scenes. So, to summarize this section, the engine of TDD is a rapid, automated cycle of identify, test, fail, implement, and repeat. Let's jump into Section 3, the core benefits of TDD. Why do developers willingly put themselves through this rigorous cycle, and what value does it actually bring to a team?
Before we list out all the benefits, we absolutely have to define a vital concept: regression testing. This is the process of rerunning all past tests whenever you change a system to ensure you haven't accidentally broken any existing features. In traditional manual testing, regression testing is an absolute nightmare. It's incredibly expensive and it takes forever. But with TDD, because you've been building automated tests for every tiny increment right from day one, regression testing becomes entirely automatic and practically free. This is arguably the single most powerful advantage of the entire TDD approach. And beyond regression testing, this approach gives you a full spectrum of incredible benefits. First up, code coverage. Because you write a test for every new feature before you write the code, every single line of your program is tested by default. Second, as we just discussed, regression testing becomes automatic and wonderfully cheap. Third, simplified debugging. Think about it. If a test suddenly fails, you don't need to boot up complex debugging tools. You already know the bug is hiding in the handful of lines you wrote just seconds ago. And finally, system documentation. The automated tests themselves act as a perfect, always up-to-date manual, showing other developers the exact intended behavior of the code. To recap, TDD gives you free code coverage, cheap regression testing, super easy debugging, and living documentation. Moving right into Section 4, limitations of TDD. Because as an engineer, you have to realize that no single technique is pure magic. It won't solve every problem. For instance, test-driven development is notoriously difficult to use with old legacy systems. If you've inherited an ancient system where tests just weren't written initially, you can't easily break it down into testable, tiny increments now. It is also highly ineffective with multi-threaded systems. In multi-threaded programming, different threads interlease completely unpredictably at different times. This means a test might pass 1 minute and fail the next, simply because the execution order shifted, which makes TDD highly frustrating and unreliable in that specific context. And here is a massive misconception I see from students all the time. People think TDD replaces system testing. Let me be clear, it absolutely does not. TDD is incredibly good at checking that the code does exactly what the programmer intended, but system testing is still entirely required. System testing validates if the overall software actually meets the user's real needs. It checks the system's performance, and it ensures it doesn't produce unwanted outputs. Basically, TDD is for the developer, system testing is for the user. To recap our limitations, TDD is really tough for legacy or multi-threaded systems, and it never, ever replaces testing the actual system against user needs. Finally, we've arrived at Section 5, Summary and Exam Focus. Let's cover the key takeaways and highlight exactly what you must remember for your exams. Grab your pens and take careful notes here, folks. For your exams, you need to ensure you can seamlessly list the 5 steps of the TDD cycle. Identify, write test, watch it fail, implement, and repeat. You must be able to clearly define regression testing and explain exactly why TDD makes it so cheap and effective. And fundamentally, you need to realize the core philosophy here. TDD flips traditional programming by forcing developers to truly understand what a piece of code's behavior must be before they ever write the program. If you don't know what it should do, you literally can't write the test for it. I'm going to leave you with this provocative thought as we wrap up this explainer. If TDD only ensures our code does what we as developers intended, and it doesn't replace system testing, how exactly do we ultimately validate the entire system to ensure it's ready for the customer? That question perfectly sets up our next lecture on release testing. Thank you so much for joining me for this deep dive into test-driven development. Review your notes, memorize your 5 steps, and I will see you in the next explainer.